The icky slime species of fish inhabits a secluded cave, and the number that can inhabit this cave is limited by both space and available food. The icky slime are found to grow at a rate determined by the equation dp dt is equal to 0.001 100 take away p squared, where p of t equals the number of icky slime after t weeks of growth. Initially, it was found that there were 20 icky slime growing at a rate of 6.4 fish per week. Using the growth rate equation, sketch the expected graph of p of t versus t on the axes below. Okay, we can see that this is a carrying capacity, and so it's going to tend to 100. Once again, just like the previous question, we could actually use the differential equation plotter to sketch this using the initial conditions 0, 20, if we want to get reasonably accurate, and then draw what we get. And it will look something like this. Probably should spend a bit more time on it than I did just there to make sure you get 2 marks. Using the increments formula, estimate the number of icky slime in the cave 2 weeks after there were 60 icky slime. So, dp dt with p equal to 60 is 1.6. It's just a case of substituting 60 into the differential equation we were given. Delta p then is going to be 1.6 times delta t, which is 2 here, which is 3.2. So we've got 60 plus 3.2 is 63.2. And you can't really have 0.2 of a fish, so I personally would give that as approximately 63. Using separation of variables, show that 100 minus p is a, bt plus c, where a, b, and c are integer values. So we have the integral, let's separate, dp over 100 minus p squared is equal to the integral of 0.001 dt. So the integral of 100 minus p to the negative 2 dp is equal to 0.001 t plus a constant. So we've got 100 minus p to the negative 1 divided by negative 1 for the power, but also negative 1 for the differential of the inside. That is equal to 0.001 t plus c. So 1 over 100 minus p is 0.001 t plus c. P is equal to 20 when t equals 0, gives us that c is 1 over 80. So we can write 1 over 100 take p is equal to 0.001 t plus 1 over 80. And putting it all over 80 on the right hand side there is 1 over 100 take p is 0.08 t plus 1 over 80. So it's multiplying that top and bottom by 80. Turn it all upside down, and I think I made a mistake there. Yeah, there's 100 take away p like that. So 100 take away p is going to be 80 over 0.08 t plus 1. Now, what we want is for these all to be integers. So I can achieve that by multiplying everything by 100 on the right-hand side there, and that will give me 8,000 over 8t plus 100. And then there's a common factor of 4. So 100 take p is going to be 2,000 over 2t plus 25, giving me A is 2,000, B is 2, C is 25. Suppose that instead of the initial number of icky slime being 20, there were 120 due to an illegal dumping of additional icky slime into the cave from another region. Explain why the differential equation dp dt is equal to 0.001 100 minus p squared would no longer be appropriate to model the growth in the number of icky slime. Suggest a more appropriate differential equation for the case where p0 is 120. Well, the carrying capacity we know was at 100. So if we started at 120, we can't have a differential equation that's going to give us growth from that point. It really does need to come down towards the carrying capacity. So you need to explain that, and I would suggest that what we do is just stick a negative in front of there, so that it does come downwards.